Sorry. So good morning, good afternoon, good evening, whenever you're watching this video. This is my second try to get through this lesson. I apologize for not being there today, but you can watch this video at your own leisure to reinforce your concepts of sinusoidal functions. For example, we looked at y equals sine x, we looked at y equals cos x, and I wanted to make sure you had completed notes. So feel free to pause the video at any time. And we'll just do one extra thing. This video might also be kind of long. So feel free to refer to your notes as you're kind of following through the lesson. And as always, definitely ask me for questions when I do see you again on Tuesday/Wednesday. Let's get to it. I'm going to share my screen with you, and we're going to take a look at the work packet, handout package that we gave you. I've modified it a little bit so that you can kind of see what I'm going to be writing. Just give me a second. I think it's this one. So hopefully this is working for all of you. Let me just modify my tablet so you guys can see it. I have to move it. I also have my calculator set in degrees off the camera. Just move this so not distracting. And so this was the stuff that we're looking at from your package. And as you pause, or if you see the question example 1, determine whether the graph represents a periodic function. If it does, determine whether it represents a sinusoidal function. For the first one, for sure the answer is yes. This is clearly a sinusoidal function. It's wave-like. There is a midline. And let's just emphasize the equation of the axis right here. Most of you can see that. So the EOA for this one is y equals -3. Amplitude, we'll use purple. A lot of you can see that the maximum seems to be maybe up there. The minimum seems to be down there. So the amplitude, you can actually either look at the graph or realize it. It is probably 2. Remember, amplitude is just the absolute value for that, meaning we only take the positive answer. So if you wanted to do it empirically as the formula, it is the maximum minus the minimum divided by 2, or you actually see the values, -1 minus -5 divided by 2, which is -1 plus 5, which is 4 divided by 2, which is, of course, 2. So notice we got it faster by looking at the screen. The period is a little bit tricky, but if you take a look at it, I think the maximum is occurring maybe at a value on the x-axis at 1.5, and the other maximum occurs at 8. Oops, so we should just change up this color. I'll use green if that's okay. So that's this distance that I'm measuring. Okay, so that's what I'm seeing. Now feel free to debate. This was definitely open-ended. So the period would be 8 minus 1.5, and that's what we're going to see for that cycle, right? So it's actually easier to see it as I'm tracing over it. 8 minus 1.5, I think is, let me just double check, 6.5 units, right? So that's all we have to do for that one. Now question B, for sure it's periodic. For sure there's an EOA, but I would not say this is sinusoidal because it's not exactly like that wave. So there's some distortions here. So I would not say this is sinusoidal. Question C, it also looks sinusoidal, but notice the midline would be like right through there, something like that. So this is not periodic. And clearly for question D, it is a repeating pattern, but it is not sinusoidal. So not. So hopefully that answered a lot of your questions. Feel free to pause the video. This question is looking at making sure you know how to use function notation. And so this question says, if h at x equals sine 5x minus 1, calculate h at 25 degrees. So just to give you an outline, we're just seeing if you can actually use your calculator to evaluate things. I'm off screen, so I think you understand what we're going to do. H at 25 degrees literally means we're going to take our calculator and we're going to input 25 degrees into there and output the answer. Now, I would not expect you to actually do this in your head. That is why, again, what we're going to get is, I think it is 125. Whoops. Sine of 125 degrees in there, minus 1. And this is just calculator work. It is not one of the special triangles. So I'm going to get a decimal. I'm going to show my intermediate step so people can see it. Okay. And then, of course, subtract 1. So all this is just calculator work, but I wanted to showcase something that you are slowly going to be eventually understanding, and it will pop up in the future. So one more time, this is a refresher. You know that y equals a, and if this is our function, k, oops, and I used the wrong bracket. Square bracket there, x minus d plus c. Well, when we're talking about sine and cosine, this is what we're going to be looking at. So in our unit in chapter 6, what we're going to get is y equals a, and I'll write sine. Oops, and I think we're using blue. Okay, x minus d, c, or y equals a cosine, okay, x minus d, c. So even though we haven't really explained it, I think some of you are understanding slowly. Emphasize that the -1 in this question is clearly a c value. And so that probably means a vertical shift of the parent function. Now, we really haven't talked about the parent functions, or I haven't emphasized it, but I think you know that our parents are either the sine graph or the cosine graph. Those two waves that we looked at when you were actually drawing it out. So what is this 5? Well, 5 is not a, and it's certainly not a d, because it would be in front. The 5 is a k value. And I'm going to give you the definition kind of right now. It relates to, I just spelled that wrong, relates to, period. Notice I'm not telling you that it's exactly the period, but we'll take a look at that. So hopefully this makes sense. Let's keep on going. Using the graphs of f at x equals sine x and g at x equals cos x, determine all values of x where 0 degrees less than equal to x, less than 360 degrees. So I'm going to sketch this out, and you'll see me actually practice this. So I'm going to show you what I'm talking about. F at x, I'll do it over here off to the side. It's going to look something like this. Yeah, that's x, that's y. Some of you already noticed I'm doing some markings here. And this is clearly sine x. Keep that in black. In blue, g at x equals cos x. This one's a little bit harder for me to trace out here. Some of you notice what I'm doing here. Just so that you have a reference. So I'm not going to be flipping back and forth through the files. This is our cosine. So this is now just making sure you read off a graph. When f at x equals 0, so f at x is this one. So just make sure everyone's following along. F at x is this one here on the block. Again, you can't see that I'm using my mouse or my marker pen. So this is our 0 here, that's 0 here, that's 0 here. So when f at x equals 0, what are those values of x? X is going to be equal to 0 degrees, 180 degrees, 360. Right? And you can check this. How? By looking at example 2, by plugging it into the function, right? Now in g at x, we'll use orange if that's okay. You can see that. Maybe I should not use orange. We'll use a different color. Maybe we'll use purple. We're looking at the function of the cos x. So that's the value here and here. So when g at x equals 0, notice what those values are. That x value is going to be equal to 90 degrees and 270. So it seems like it's the opposite, right? The last one is really straightforward in green. When f at x equals -1, where's -1? That's there. And that value happens to be really easy. X is equal to 270. Okay, so I used the graphs and I went really quickly. Feel free to pause the video by looking back at what we did. The last one's interesting, and I wish I would spend more time. So if you're not too sure, I can talk about this one again. Example 4 says, determine the coordinates of point P, X, Y, resulting from the rotation of 70 degrees centered at the origin, and starting from the point of 3, comma 0. Now this question is interesting because the radius is actually 3 units, not 1, which we normally have our unit circle. And I'm just going to trace it on block so you can see it a little bit. That's our unit circle of 1. So we have a related acute angle that's going a little bit larger for the radius of 70. And if you recall what I was showing you, xy is now the coordinates of cosine x, comma, sine x. And this means, of course, what we're going to use is that value of that angle. So all you have to do is take your calculator, find out what cosine of 70 degrees is. And I'm going to use my calculator off screen. Cosine of 70 degrees happens to be 0.3420, and it keeps on going. Sine of 30 degrees, the 70 degrees, sorry, using my calculator again, is 0.93969. And just to share with you, that would be this point right there. So these are the coordinates of if the radius was equal to 1, the coordinates would be roughly 0.342, comma, 0.940. I'm just rounding that to 3 decimal places. But because we have a larger one, then I don't know if you can see it. I'm going to make it larger so people can see it. This point over here, it is clearly a related acute angle. So what are we going to do? We're going to multiply. Oh yeah, we're going to multiply? Or are we going to add? No, we're going to multiply. Mr. Chen. So now if r equals 3, now I'm doubting myself. I might have to redo this question again. If r equals 3, we're going to simply do 3 times that cosine 70 degrees and 3 times that sine 70 degrees. So 3 times cosine of 70 degrees. Yeah, that could be right. That's the right answer. This is going to be 1.026, and 3 times sine of 70 degrees is 2.819. And it looks like it. Yeah, it looks like it. Good. And you can check this answer, seriously, by those points by simply squaring the x value of this, so x squared, this one here, and squaring this one there. And it should equal the squaring of 3 squared, which is 9. So if we square those numbers, it should work. Let me just test it really quickly. Watch me lie to you. Oops, squared plus 2.819 squared. Yeah, it's 9. So that's kind of neat. I'll do this one again. I don't really like how this is taught here because the unit circle and the degrees should be there. But basically, the hint for this lesson is, in short, it is r, or I should use lowercase r times cosine theta, the angle, comma, r times sine theta. That is the lesson. Okay, let's get to the meat. So what I wanted to do, and again, feel free to pause the video, is actually just graph for you one more time officially y equals sine x. And the reason why I'm doing this is because I want you to understand that this is the graph that we get. And I'm just going to draw one cycle over here, which is the counterclockwise one. And we'll use a slightly different color. We'll use maybe a nice blue to show what I'm talking about. Some already know what I'm doing. Just so people can see this nice wave. So we haven't really talked about the fourth characteristic just yet, but I think you understood that maybe sine and cosine are related because the cosine graph is kind of the sine graph shifted, right? And shifted, of course, horizontally. Now, this is a little bit tricky, so feel free to pause the video if you need some help, but I'm going to give you the summary of what you already kind of should know. First of all, the amplitude of sine graph is 1. The period of our graph is 360 degrees. The equation of the axis is clearly y equals 0. That's the horizontal line. And PS, well, it stands for phase shift. And we tend to use PS as a short form for that. In this case, there is not, because this is considered the parent function or base function. So I wanted to see if you could do our next analysis. And basically what I want to do is give you the graph. Because you've been practicing already, hopefully, how to graph these sign functions. So feel free to pause the video as you're looking at this. And I just did this in Desmos. And many of you can actually analyze this with no problem. Now, we haven't really talked about phase shift, but I think if you're thinking in terms of sine, okay, let's just go back up so people can see what I'm talking about. Many of you are looking at this 0, 0 point, right? So that's kind of what a lot of kids do. Now, don't get me wrong, cosine is actually easier to work with, but sine, I just wanted to make sure you're all right. And I just made this up, and we're going to practice this in class. So can you actually do the analysis for this question? And I don't think many of you are incapable, right? It's actually quite easy to see because a lot of you can actually see that the maximum, and maybe if you have to zoom in or pause the video, the maximum seems to be there. The minimum seems to be there. Many of my students can actually do this. In fact, when I tell my students to do the analysis, most students can actually do these 4 things. Now, if I'm going too fast for you, that's also okay. Please ask me, and I will definitely help you out when I see you again in class. But I think a lot of you know what I'm trying to do. We're trying to find the equation of this function that has been transformed, right? Now, eventually, you will transform functions given the equation, but I think you'll be okay. And again, this video is already running long. So let's just see if I can speed this up. First of all, the maximum happens to be at 2. The minimum seems to be at -4. And again, you can use the formulas that we have, but I think a lot of you can actually tell that the amplitude is going to be 3 units. The equation of the axis, if we do 2 plus -4, divide that by 2, I think that is 2 plus -4 is -2. -2 divided by 2 is -1. So y equals -1. And let's emphasize this right now with the red line. So at -1, that is the equation of the EOA. So notice we've been talking about, the EOA cuts it exactly in half, the midline, and you can clearly see, and as we showed the purple here, that's 1 unit, that's 2 units, that's 3 units, so that's 3, right? So that's the amplitude. So you have 2 of the 4 criteria. And if you look closely, what is the length of the period? We'll use green again for this. I think you can see from that maximum, this distance is that 1 cycle or the period. And many of you actually can tell me that this period happens to be 360 degrees. That's not a big deal. The only problem is the phase shift. And so if we go back, and I apologize, the scale is still the same, but it's a little quirky off. If we go back here, notice this graph is 0, 0, one highlighted in yellow. And then this one here, where would that point possibly be? Well, I think you can see the transformation. It's probably right there. So this is called a phase shift. And folks, I think you already understand what I'm doing. It seems like it went left 30 degrees, or actually -30 degrees if you actually look at the value there, -30. So what is the equation of this function? Now, I am skipping a little step here because I told you that 360 is related to k value. So it's related. Oops, that's not a good symbol. So this is related. Okay, I'm just going to write here the answer. And some of you will understand what I'm doing. Y equals 3 sine. The k value is 360, and I'll explain that later. X. But I just wanted to get this phase shift. So what are we going to write? Plus 30 degrees, because it's the left. And don't get me wrong, there's actually other answers. -1. So you're already understanding now, I think, that the -1 is the EOA. I think I did purple. So the purple value for 3 is the amplitude or the A value. I I didn't use this blue. Let's use this blue. This plus 30 degrees is that shift. That's this. And the only thing that we haven't really talked about is the period, but that period is related to the invisible one here. So I'm going to stop the video there. That is the equation of this sinusoidal function, y equals 3 sine x plus 30 degrees minus 1. And how could we check this answer? Well, let's see if you can check this point. Try to check the point 240 degrees. Some of you say, well, I don't know how to do that. Well, if you go back way to our very first question, or second question, can you find that value? Calculate when h is 25 degrees. You can now try to do it to check to see if it's going to equal 240. And I guarantee you, when you plug in 240, make sure you calculate in degrees. 240 plus that 30 degrees, take the sign of that, times it by 3, subtract it by 1, and we'll get a value of -4. So just wanted to thank you if you stuck it this long to the YouTube video. And as always, I'll see you on Tuesday. Again, our test has been moved. My apologies for that. But hopefully this helped when watching this YouTube video. Thanks for watching.